usually find that I can boom enough to, especially in this size. So good evening, thank you very much again to the committee, BCS Software Group, for inviting me. Nice to be back. It's exactly 2 years since I was last here, because I know because I checked in on Foursquare and it assured me that 2 years ago I was in this building. And yeah, so as Chris was saying, a couple of years ago I was here and I spoke about messaging, Internet of Things, lightweight messaging in devices and things, and I've moved on. I'm now a slightly different part of my career. So, Andy, you can find me online in all kinds of places. I was reminded this morning by my cloud-enabled little printer that I was speaking here today, so I remembered to drive along the M40 to get here. So my job title is developer something called Cloud Foundry, which I will talk about briefly, but I'm not here to promote in any particular way. I've got a slightly different slant and approach this evening. I'm into all kinds of interesting things, I like to think, particularly open source technology and different projects. Just for background, so you know kind of what qualification I have for saying anything here this evening, so that I don't stand here and hand wave. I was actually in Oxford a number of years ago, and so I was saying to Chris earlier, it's always interesting to come back to the city and see what's changed on the core market and the high street in the last couple of years. It seems to move quite quickly. And then I spent, via another company, I spent 10 years with IBM, doing a bunch of things, working with a lot of different companies as a consultant, primarily around what we call business integration or enterprise application integration, or it's gone through various phases of its life, something like service-oriented architecture today. I'm still involved with a project at Eclipse around lightweight messaging, called MQTT. And then 2 years ago, I moved from there. I had a great time at IBM, and I moved to this company, VMware. If you haven't heard of VMware, they are one of the companies that really invented virtualization on distributed systems. Arguably, IBM had virtualization on the mainframe many, many years ago. But VMware was the company which, again, arguably brought that to PC hardware. And then last May, VMware and their parent company, EMC, spun us out into a new company called Pivotal. And I'll very briefly mention why a little bit later on. But I've been working on this project called Cloud Foundry for that period of time. So, enough about me. Let's actually talk about hopefully what you came to hear about and what you're expecting to hear about, and that is cloud. But which cloud? For goodness sake, what do we know about the cloud? Well, I'm sure you've all picked this up in W.S. Smith's. It tells you everything you need to know. I recommend it strongly. It says Gmail is the cloud, and Google is the cloud, and we're all good. Of course, reading that kind of thing leads to situations like this, where people just don't really understand what on earth cloud is all about. And, you know, the obligatory joke, looking at this Citrix study, I'm not going to expect you to squint and read this in detail. I've picked out a few of the highlights of this August 2012 survey that Citrix did. Of course, it's a US report. So 29% of Americans apparently thought that cloud computing had to do with an actual cloud. 51% believed that it was affected by the weather, which, of course, in the case of something like Hurricane Sandy in New York a couple of years ago, it has been. 54% of these Americans polled said that they never use anything to do with the cloud. Everything's to do with their desktops or their mobiles. That's nothing to do with the cloud. But then as soon as you actually start to dig into what we mean by cloud services and cloud computing, many of them do turn out to do so. So, when I was here at Oxford, my degree was actually history. So I have no academic background in computing. I've always been very interested in it. I've had a fantastic 20 years now since leaving, which is always a scary thought, working with technology. So I'm going to take a little bit of a historical look at where we are. I'd like to split my presentations into kind of 3 points, so that we can kind of understand where we are as we go through. So talk a little bit about cloud in general and how we got to where we are today. Focus then on this piece called Platform as a Service, or otherwise known as PaaS. Cloud Foundries, that's what I've been working on for the last 2 years. And then finally, I want to talk about why I believe that open source, in particular, is really important, and particularly important in the cloud. I will probably speak for about half an hour, 40 minutes, and then after that we'll have some conversation, questions. Does that sound okay to everybody? Great, excellent, thank you. So how did we get here? Well, arguably, again, all of these things are open to debate, and I'm sure that some of you may debate at the end of the evening. There's been kind of 2 or 3 eras we've been through, and if we look at the first one, we might consider the first one to be kind of from the 1960s through to the 80s, and that was the era of the mainframe. So IBM and ICL and other companies were building these very large computer systems that were very much about centralizing information and processing information in a batch-oriented manner, because networks were fairly underdeveloped, and they were primarily being used for automating financial systems, airline reservation type systems, things that you could do in a batch-oriented manner. But then in the sort of late 70s, early 80s, with the dawn of the PC era, we moved into client server, kind of characterized by the rise of operating systems like Windows. And in an enterprise space, what we started to see was much more around CRM and ERP, systems being used for email, and then really into the 90s to 2000s, we moved into that web era that we've been enjoying, the World Wide Web. And those 2 eras have primarily been characterized and driven by enterprise, business. Obviously, academia as well has been very important and has been using these systems, and particularly with the advent of the personal computing era, more consumers have had computers. But those 2 general eras have been driven by the requirements and needs of the enterprise. So big systems, often networks as we came into the 90s and 2000s, but trying to deal with information within business. But then, as we move forward, we're really now in this cloud era. And there's kind of been a blurring, because people just assume that, and I hope people can read this. I haven't really thought too hard about the level of requirements at the front of the room here. Although we might think about, well, we've had the web now for sort of 20 years or so. We've all been using Netscape Navigator, Internet Explorer, and other things. Well, haven't we been doing cloud stuff for a while? That's entirely true. But when we look at the adoption of cloud technologies and what cloud data centers have enabled, as it says here, the new consumer internet giants, the Googles and the Facebooks, and the eBays and the Twitters to achieve, those things have been achieved because those companies have not been saddled with the enterprise legacy of having to deal with mainframes and client-server computing. So they're really dealing with massive amounts of data, the infamous big data, which I'm sure you've had talks about here at BCS Oxfordshire in the past, or will have, because it's another one of those buzzwords that's not going away anytime soon. And these companies have been successful by reasoning over that data very fast, developing software in a very agile way, and delivering it in a continuous manner. So unlike in the enterprise where most projects, business will go and ask their IT department, I have this new requirement for a new project, a new application, when will you have it delivered? And the enterprise IT manager will say, 18 months time, there you go, 18 months, it's always the answer. With consumer IT, with our mobile devices, we're getting new versions of these apps rolled out to us on a continuous basis. Almost daily, we're getting updates to the apps we're using. And that's all enabled by the fact that we have these new fabrics today. So, I'm sure many of you will be familiar with this kind of division when we think about the cloud. We usually divide it into these 3 layers. We start off with top-down, I'll talk about it this way, software. So, I mean, we're consuming the software that runs on top of the cloud infrastructure. So those kind of things, arguably you can go back to Yahoo and things like Flickr, software that you're consuming through a web browser. Gmail, Google Docs. Going right down to the bottom of the pyramid, a lot of this stuff's been enabled, and I'll dig into these in a bit more detail in a moment, by infrastructure clouds. So some of the infrastructure as a service technology that you may have heard of, Amazon is a very big name, and we'll hear more about them as we go. Amazon Elastic Compute, EC2, is their infrastructure. Google in the last 18 months has moved into the same space with the Google Compute Engine. And then there's open source options like OpenStack, and my former employer VMware has a very successful commercial closed source product called vSphere. But in between that, you don't just run those web apps on raw hardware, on raw infrastructure, on raw virtual machines. There's a platform layer, and this is often quite visible because we as consumers are dealing with the software, and hardware engineers are racking up servers and creating virtual machines. But there is a middle layer, and it's characterized by some of these technologies. So Google has a product called App Engine that kind of kicked this whole space off in about 2008, which really isn't that long ago, 6 years. A very, very big name is Heroku, which was bought by Salesforce a couple of years ago. I work on a product called Cloud Foundry, and there are some others in this space as well. So this platform layer is really the middleware, enabling software developers to deliver that software without having to worry about that bottom layer of the infrastructure. Okay? So let's look at that in a little bit more detail. My argument and suggestion to you would be that Amazon has been enormously successful. It's probably the biggest name in this space right now. Everybody who wants to be in infrastructure as a service is trying to beat Amazon. My former employer, IBM, frequently tries to say, look, hey, we're big in cloud, and they are. But they were the ones that invented the mainframe and the PC. And a bookseller beat them to being the biggest name in cloud, with the greatest respect to IBM. So Amazon really brought, when they announced Amazon Web Services, which is now this huge portfolio of different technologies, when they announced their Elastic Compute product, which is really just the ability for me or you as consumers or developers to say, I would like a virtual machine. I don't need that virtual machine to run on my local hardware. I'm happy for it to exist somewhere else remotely. I want to get it on demand. I don't want to wait for somebody to configure it and create it for me. And I want to use it for a minimal cost, a couple of cents an hour. They really kick this whole space off with infrastructure as a service. And companies like Microsoft and Google have been playing catch-up, and many other companies, especially in the enterprise space where I spend most of my time, are trying to compete. Companies like Amazon built out these, what we now call infrastructure clouds, because they needed to. Amazon was becoming a rapidly scaling and highly successful retailer in the 90s and in the 2000s, I should say. And in order to support that growth, they needed to create this kind of pool of computing resources that they could pull on and they could deploy their website to and enable transactions to. So in order to support that software that consumers were interacting with, Amazon and others, Google and Twitter and others, created that infrastructure cloud technology. So how about that other massive giant of cloud, Google? Well, I would say the really interesting thing about Google is that they've also been playing catch-up to Amazon. Google started, as we all know, as a search company, and they've grown a really interesting portfolio of products around that core search and later advertising capability. The interesting thing that Google did was that they didn't immediately say to everybody, hey, come use our platform and run your apps on Google. What they did was they said, hey, come use our APIs, use our data, hook your applications into us. So Google's been relatively late to the cloud infrastructure and cloud platform game, although they did bring out Google App Engine, which is a platform as a service, middleware for running applications, in about 2008, 2009. It's only last year, or 18 months ago, that they actually started letting you request raw VMs running in Google data centers. So Google really was powerful in what we call the Web 2.0 era. So Tim O'Reilly famously coined this phrase Web 2.0 a couple of years ago, 5 or 6 years ago now, to define this kind of age we were in where you could really quickly write web software calling into different APIs over something like a RESTful HTTP interface, and moving a long, long way away from client-server computing, local RPC calls, statically linked libraries. We're talking about making remote calls to highly powerful compute engines and accessing data. And I also have introduced this other term down here, MBAAS, mobile backend as a service. So in order to support this growth of mobile computing devices, and the fact that we've got these small apps running everywhere, another kind of element of the cloud, subset of the cloud, is this idea that that data lives somewhere, and that these things are just backends for the client side of computing. So that Web 2.0 era was kind of characterized by this idea of mashups. Who remembers mashups? You could start using Google Maps to take a data set and mash it up, and you could come up with something really interesting. Well, that's just kind of part of the fabric now. It seems like every mobile app I get has like something that lets me look up, something on a map locally, because it's useful. Location is useful. So that mashup and that back-end API was really, I think, kicked off by Google's initial openness to enable you to access their data sets. But both of those companies still need to build and manage a platform. What do we get when we get an infrastructure as a service compute engine? Either an Amazon EC2 VM, Google Compute Engine VM. It's like in the 80s and 90s when we used to go to the computer store and buy a beige box. And what was in that beige box? Well, there was a CPU, and there was a disk, some storage, and then towards the end of the 80s, early 90s, you started to get a network, a modem, and then later an Ethernet card. So you get network, storage, and compute. And then, of course, everything came with Microsoft Windows, because Microsoft did a great deal with all the computer manufacturers, and of course, everything had Windows. Fine, let's just move on past that. The point of Windows and any other operating system is to manage and make use of those hardware resources. Okay, so when we go to Amazon, we go to the Amazon Web Services console. I don't know if any of you have ever done this. You click login with your Amazon account, which is already got their credit card details from there, so they're happy with you. You create a virtual machine, and then you choose what operating system you want. But the point of choosing that virtual machine is you say, I want a large, medium, or small machine with one or more virtual CPUs or slices of CPU. Those of you that have used mainframes will be very familiar with these same concepts. Some disk, some storage, and some network. And that's what you get. But you can't do anything with it until you install that virtual operating system, whether it's Linux or Windows or whatever. So you need, in order to use that computing resource, an operating system. Along came another company. We kind of step along our historical timeline, called Heroku. And Heroku started off as a company that was enabling developers to just deploy apps written in a language called Ruby to the internet. So they came up with this really interesting idea that any developer can sit on their local machine, write some code in Ruby, test it locally, and then run this push command, Heroku push, or Git push in fact, because it's connected to the Git version control system, and then it would be running at a URL on the internet. Tremendously powerful. Suddenly, I as a developer have never even had to go ask Google or Amazon for a virtual machine. I've just got my app running at a URL on the internet, and I can give that URL to anyone. Completely decoupled as a developer from that infrastructure there. And more interesting than that, they can then say, well, actually, my app is running out of resource. I need to scale it. So you can, again, run with a couple of simple commands, give me more instances of my application. That enabled developers to start to push code really, really fast. Along came big business. By big business, let's take an example. Well, there's a company called Netflix, who are relatively new in the UK. I've been in the US for a long time, and initially in the US, what they were doing was they were enabling you to rent DVDs. So they were challenging the likes of Blockbuster and other video and DVD stores, traditional bricks and mortar. But what they did was they rapidly pivoted into streaming, because we have this cool thing called the internet that we can stream video over. And then they started to insert some really interesting analytics so that they could work out what your interests were, what kind of things you were watching, and recommend you more stuff. And you sign up for their service. I'm a very happy Netflix customer myself, and you can choose from this massive library. That's a real business challenge. It's a challenge to all kinds of traditional bricks and mortar stores, traditional business models, and the way that Netflix started to use the cloud, because they are based on Amazon's cloud, and the fact that their customers were demanding reliability from that cloud, when Amazon typically gives you very little reliability, meant that Netflix starts to innovate on top of the cloud. So if you look at some of the things that Netflix has been doing in cloud computing, they've been coming out with some really interesting projects, both in the big data space around analytics, preferences. They ran a competition a few years ago that asked coders to improve their recommendation algorithm by just a few percentage points, because it was such a competitive space and such a tight thing to improve, where the winners went away with a lot of money. Not only are they doing things like big data, Netflix has got another project called Chaos Monkey. Has anybody heard of Chaos Monkey? So Chaos Monkey, the goal of Chaos Monkey is to actually run around Netflix's virtual data center and randomly kill things. Okay? Assume when you're writing code for the cloud that things will fail, because you're running at such a scale that over time, given the balance of probability, different resources, be they disk or CPU or whole virtual machines, are going to fail. So they actually wrote some code to force their coders to design for failure. Because when you start moving up to this kind of scale of computing, these are some of the things you need to design into your system. So let's look at some of the characteristics of these kind of cloud systems we're talking about. Well, first of all, I mentioned scale. And when you look at something like Netflix, they're running in a number of Amazon data centers, and Amazon actually splits them up into regions, so US East 1 and 2, and US West, and Europe 1 and 2. Within those regions, they then divide them into availability zones. So you can have your app running in more than one zone, which guarantees there are more than one set of physical hardware and data centers if there's a power outage. On potentially hundreds of VMs in order to support the fact that lots of people want to get access to this data. Lots of us want to tweet simultaneously during the Olympics or whatever. There's a decrease in cost of all of this because as hardware becomes more commoditized, we become more efficient at running systems at scale. The overall cost is going down over time. So you see Amazon and Google in a constant race to the bottom for the cost of their computing resource on offer to you as a user. The ability for developers to deliver in a very fast and agile manner. Facebook has a famous quote, something along the lines of, fail fast, right? Write code quickly and fail fast and move on. My brain is completely blanking on what the actual phrase is. I apologize. With the ability for us to grab data, and this is where the NSA jokes come in, and I'll case it further later. With the ability for us to grab and store data and reason over it very, very fast, we can iterate and improve products very quickly as well. And this is the problem that enterprises have right now. Because a lot of the companies that I'm working with, have done over the course of the last 50 years, are saddled with that legacy problem I referred to. They don't have processes or systems in place that enable them to fail fast and test these things quickly. And often they are transactionally sensitive systems anyway, so they don't really want to do that. But actually the competitive advantage today in business, the companies like Airbnb and Netflix and Square who are challenging those traditional enterprises, are being able to reason over these things and iterate their product quickly. So it's again that difference between the 18-month project delivery cycle and the few days it might take to write and try something out quickly. So my argument is that to succeed where those companies like Netflix and Square and Airbnb have done, you need an agile platform on top of that infrastructure. Because it's absolutely possible for a company today to rack up hundreds of servers in a few data centers around the UK or around Europe, install some virtualization system, infrastructure virtualization system like OpenStack or VMware, create a pool of VMs and have a cloud. But that doesn't necessarily mean that you're able to be agile. Because you may still be saying, well, actually, you still have to phone up the operator of the ops department and have your VM provisioned and get the SSH key and log in and install the packages you need. So let's talk about platform and platform as a service. Well, in platform as a service, what we're focused on is applications and data services. We do not care. We have de-emphasized this infrastructure and hardware. I do not care which VM or how many VMs my application is running on. I don't care about the kernel version of Linux that I have running underneath it. All I know is I'm writing an app in Go or Java or Ruby or Python or whatever I choose. I want that to be running somewhere and be available. I'm an application developer. My job is to deliver some functional code, something useful to you as consumers. And I don't care about all of that operational stuff underneath. It works. Broadly speaking, OpenStack and VMware and other things are highly sophisticated and, if not good enough, systems for running code. These are opinionated systems. Platforms as a service are opinionated. And what I mean by opinionated is actually very much like what I mean when I say Apple's hardware is opinionated and operating system is also opinionated. It's not open source to the extent that Linux is, and this is slightly ironic given where I'm going with the rest of my talk this evening around open source. I am in a walled garden owned by Apple, and I have to live with some choices they make. I may only run apps, that's like a ticker box that says I trust everyone in the world to run code on my system. I only run apps from the Apple App Store. In the same way, the platform as a service is going to be opinionated. It may only give me a certain amount of memory for each instance of my application. It might only allow me to use one or two frameworks rather than absolutely everything. It might not let me get shell access to the virtual machine my application is running in because, quite frankly, it doesn't matter whether I can SSH in and fiddle around in a terminal anyway. I want my application running. So the goal of platform as a service is really to be this kind of operating system layer I alluded to earlier. Okay, so it enables us to run that software on top of that virtual hardware, that virtualization layer. So, I don't know how many of you looked at all at this area. I mean, clearly I live and breathe this stuff, so it's one of those things that I pick up articles. Beginning of this year, last month, there were a bit of toing and froing about platform as a service. There are some people who say, platform as a service is dead. Infrastructure as a service is where it's all at. Amazon is running away with the game. Google's coming up fast. Who cares about the platform as a service? Gigarohm, analyst firm, and journalists actually said, PaaS is dead. The important part about all of this and the web generally in the cloud is services as a platform. Our very own BCS, the same week, in fact a couple of days before, talked about why PaaS is going to be the next big thing this year. In the same way that 2014, I guarantee you, will be the year of Linux on the desktop. which of course it has been every year for the last 10 years. It's also going to be the year of the Internet of Things, in case you haven't heard, just because the technology industry needs to keep getting ahead of things. But quite frankly, and this is my personal opinion and a statement of where I am and the conversation I have in my day job, lots of companies are waking up to the realization that they have got 30 years of IT expertise in their company, or 10 years, or however old the company is. And a typical kind of situation goes as follows. Just being appointed the CTO of a company, I've got 10 data centers around the UK and Europe. I've got 200 people in my IT department. The business comes to me. We started this conversation earlier. I put a pin in it. We're going there again. Business comes to me and says, "Okay, Andy, we need a new accounting system. We need mobile access. We need all the sales force to be able to use it. We need, how long will that take?" And I say, "Well, 18 months." 18 months, then. We've got to do the business analysis, design it. Then we've got to go out to tender and get all the hardware in, because we can't use the same hardware that we're already using for that project. More than my jobs were big, they're nuts. Oh yeah, and I told you we had this like virtual cloud, but I really need to get the new rack of servers. So we do that. 4 or 5 months down the line, we start development. And then of course we run out of time developing and we cut our test cycle, and 18 months time, my department ends up delivering a load of crap. In the meantime, I'm not too old to have a teenage son, but I don't. My teenage son comes along and says, "Hey Dad, look what I wrote over the weekend. I was just hacking around and got this cool new mobile app I wrote." And I said, "Oh, interesting, cool. How do you do that?" He said, "Well, I put the back ends on Amazon, and yeah, I wrote it in Objective-C or Java or whatever. It's called Facegram. It lets me take selfies." And I think, okay, that's fun. So he tells all his mates at school, and they're all using Facegram by the end of the week. And then, of course, it goes around on Facebook, and all their friends are using it. So by the end of the week, my imaginary teenage son, or daughter, has created an awesome app that hundreds of people are using. And I'm thinking, well, hold on a minute, I've got like 200 people who have been in IT for 20 years, and they're taking 18 months to do anything. What's going on? And again, the truth is because that person, that developer, isn't saddled by all of the processes and requirements. So as I go around in my day job, I am talking to large banks and pharmaceutical companies and retailers who are thinking, well, we have got these data centers. They should just be virtual pools of computing resources, and why are we not able to innovate as quickly? So that's the cloud. That's my perspective on the history of the cloud and where we are. And that's some thoughts on platforms as service and why I think it's really important. And this is the part where you all look at my Mac and my iPhone and sit there with your arms folded and think, ha ha ha, yeah, open source really. Which, I take that point. I live in a walled garden. I'm aware of the boundaries of that garden. I just happen to like stuff that works, and I've been a Linux user for a long time, and I contribute to open source projects as well. So, we'll have that argument over a pint. Rewind 23 years, and I would argue that kind of 1991 was pretty important in our industry. And I would argue that 10 years ago, those of you that may have been sat in this lecture theatre at a BCS meeting, may have still been kind of wondering whether Linux was that important. But certainly in the last 10 years, it's really proven its point, particularly in business and the enterprise. So Linux is all grown up now. It's over the age of 21. It can do all the things that it's legal to do. And it runs everywhere. It even runs on crappy airline entertainment systems that crash and reboot themselves mid-flight, and you see a penguin in the corner, right? I obviously travel a lot. I like to take pictures of the penguins. Android owns a lot of Linux. Your home router almost certainly runs Linux as well. It runs in all kinds of places. And the reason that it also actually runs on a Microsoft cloud platform, which I found really funny. as a long-time Linux fan, and I won't say Microsoft hater, but certainly someone who's had some opinions of Microsoft in its past. I found in June 2012 when they announced with Canonical, hey, you know what? Windows Azure, we're going to let you run Ubuntu on it. I just kind of thought, that is game over, guys. You've been trying to push this Windows thing on us, and So it's ubiquitous, but you often don't see little tucks. It just works. And the reason it works is because it's open source. Why is that important? Well, because it means that people have adapted Linux to run in the most esoteric situations. So in really, really small devices, of course it runs on Raspberry Pis and all kinds of other devices, including some of the new Arduinos come with an embedded operating system based on Linux. And it's, IBM, it's a skunkworks project, in fact. Some guys at IBM, once upon a time, decided to make it run on the mainframe. They initially got in lots of trouble for doing that, and then, of course, IBM turned that into a massive business opportunity. So it's been so flexible because it's open source. So open source is important. Openness is important in this space. Another important thing is to recognise that there is no single one language that will rule them all. Okay, now this is a chart from a company called RedMonk. They are a UK-US industry analyst firm. They are an open source analyst firm, so they publish all of their analysis. If you're a commercial client of theirs, they will publish the analysis they do for you as an open source report. This is a bit of an eye test for you. But you can go and look up the RedMonk programming language rankings. What they do every, I think, 6 months, or possibly quarterly, is they take a look at things like GitHub, Stack Overflow, and some other sources of information, and try to work out, how popular different languages are. And there's a whole bunch of languages on this chart which I certainly had never heard of, and I would challenge some of you as well. So there's, right down in the bottom there's Gosu, and Dylan, and Boo, and some other things that I certainly hadn't heard of before I'd seen this chart. It might be a bit of a fun game if we could all come up with an assessment of how many we've heard of and how many we've individually used. But the point is that companies like Google employ some very smart people, and they seem to come out with a new programming language roughly every 6 months. Right? So Google have come out with Go, and they've come out with Dart. Red Hat have come out with Salon. There's been some real innovation in programming languages, although many of you who've been coding for a lot longer than I have will, I'm sure, say, well, everything old is new again, and this stuff goes in cycles. But there is no point in creating a platform, a cloud platform, that only enables you to run 1 or 2 languages. Why do I say this? Well, I mentioned Google a few times in that last little rant. And Google have this platform as a service called Google App Engine. The Google App Engine only allows you to write in a small subset of languages. So, for example, Python, Java, Go, and another one, PHP, I think they've recently added to the options. And that's fine if those 4 languages are the only 4 languages that we ever want to code in. The chances are that, by the end of next week, someone will have come up with a new one. And in fact, the other day, and this is a complete aside, there's apparently a German programming language. It's literally called German, and you can only, and this isn't me trying to be offensive, it's just very amusing. They're literally the only 2 keywords in the German language are Schnitzel and beer, I believe. And there's a Wikipedia article that tells you how to write hello world, because basically those 2 things are zeros and ones. Anyway, not that you're going to write much useful coding language. So, we need to be able to adapt, we need to be able to plug in new frameworks. We talked about data a couple of times tonight. I mentioned the size of data. Well, data continues to get bigger. We continue to suck up more information from the human race's ability to generate it and share our personal information in ways that we had no intention or realization we were doing. We have the Internet of Things and sensors generating information around us. And not only does that data get bigger, but our apparent need to process it and do interesting things with it gets more pressing and faster, and then we need to be more scientific and intelligent about how we deal with them. So it's not all about Hadoop, but Hadoop is simply one example. Hadoop, of course, as a technology, came from many of those internet giants I've mentioned several times this evening. And again, we can't guarantee that in the future, Amazon or Google, who only support on their cloud platform one or two data sources, those two data sources will solve all the problems we need. So we need a pluggable system. The ability to compose different pieces of function is really important in our cloud platform, in our operating system for our computing layer. So a couple of years ago, a company called VMware, who are a very proprietary closed source virtualization vendor, saw the fact that they were not the only virtualization vendor in the world. In particular, Amazon was being very successful in the public cloud. And they decided that they were going to come up with an, if you like, an operating system layer for the cloud. By which they meant the ability to run across multiple different infrastructures, not just their own VMware, but also on Amazon and on others, OpenStack for example, and the ability to plug in different frameworks. And that is something called Cloud Foundry. It's an open source project. It has been open since VMware launched it. Before I joined them, in fact, it was started in 2011, so predates my involvement. And that's all been in public the whole time. And over time, over the last couple of years, this project has grown. And again, it's not here to sell anything. It's not the only one out there. There are other television listings, magazines are available for those of you that remember the BBC adverts. The interesting thing about Cloud Foundry is that it's now growing quite an interesting community from companies like IBM and SAP and Orange and various other large technology companies getting involved. And it's all about choice. So I mentioned that it can run on multiple different infrastructures, and I've mentioned many times this evening Amazon and VMware. It can run on OpenStack. It can run on a competing open source project from the Apache Foundation called CloudStack. It can run on Google Compute Engine. And in the future, through this thing that we call a CPI, it's like an API, that's the cloud provider interface rather than an application programming interface, we can adapt the platform to run on top of different infrastructures. Because typically, when we talk to an infrastructure cloud through its API, we are asking for some virtual computing, some virtual CPU, some virtual network, and some virtual disk. So through that CPI layer, we can ask the infrastructure to provide us with the virtual hardware that we need. And through some technology called build packs, which actually came from a competitor, Heroku, we saw them earlier, we can plug in any runtime we need for our application when we deploy our application. So when we do that push that I talked about when we looked at Heroku, we push our application into kind of a bare operating system, an operating system with no personality, if you like, no virtual machines, no runtimes. And then as I do the push, the cloud platform says, hey, wait a minute, this is a Java file, so I know that I need a JVM. So it goes and downloads the JVM, installs it, so that I have a ready to use runtime when the application is delivered. And finally, I mentioned in the previous slide about data, and I mentioned Hadoop. Well, there are many data services and APIs out there, and there will continue to be new ones. So we have the ability to plug those in as well. So again, composability is key. When we look at that layer in between software and the infrastructure of the hardware, the ability to compose these software pieces is important, and that's why I believe open source and the ability to pick and choose and compose these things is really important. So I'm coming to the end of what I wanted to say. I was asked a couple of weeks ago to speak at something called the London Cloud Summit. And the topic for that was the 2014 Cloud Forecast, which I thought was quite interesting. There were a number of speakers. I was obviously in that platform space. We had some people talk about the infrastructure, cloud stack, OpenStack, and we had some people talk about the software. And I think really all I have to say in closing is that in the next year and through the next few years, this word cloud is not going to go away, I'm sorry to tell you. We are going to have more people contributing, hopefully to this open source movement in particular, and we're going to see more apps and more services being developed on this amazing technical platform we have. When we were out in the hallway, I was mentioning that technology excites me, and it excites me because of the ways that we as a community, as human beings, can adapt it to make our lives better. So I'm very, very excited about the future for the kinds of innovations the cloud is providing. Thank you very much, and I'm very happy to have some questions and have some conversation with you. Thanks.